Welcome. We are going to discuss the solution to part 2 that was done in November. So the first set of questions, you are to check whether it is possible to find a pure surd when you get sum of two surds, and then when you get to the difference of two surds, product of two surds, and quotient of two surds. Then to justify each of the answer with an example. And then the second question is to check or to find the value of k, given that the composition of two functions f and g is the same by alternating the order of operation. So let's briefly discuss the solutions to this set of questions. So the first question is to check whether the sum of two surds gives you a pure surd. So the sum of two surds. Now, the sum of two surds can give us a pure surd. So the answer for this first part is yes. We can get a pure surd by getting the sum of two surds. E.g., if I have square root of 5 plus square root of 2 square root of 5, then you see this will give us 3 root 5. Or if we have 4 cube root of 21 plus minus 3 cube root of 21, this gives us cube root of 21, which is a pure surd. And then number 2, to check whether the difference of two surds can give us a pure surd. The answer is still yes. For example, if I have square root of 3 minus 2 root 3, this will give us 1 minus 2 root 3, which is the same as negative root 3, which is a pure surd. Or even if you have root 5, 2 root 5 minus root 5, we get root 5, which is still a pure surd. Part 3, the product of two surds. Product of two surds. So yes, it is possible to get a pure surd by getting product of two surds. For instance, if I have cube root of 5 times cube root of 4 is the same as cube root of 5 times 4, which is cube root of 20, which is still a pure surd. Roman 4, the quotient of two surds. Yes, it's true that it is possible to get a pure surd by getting the quotient of two surds. For example, if I have root 10 over root 2, this I can write as root of 5 by 2 over root 2, which is root 5 times root 2 over root 2, and this cancels out. I get root 5. So it is possible to get a pure surd by getting the quotient of two surds. Then the next question was to find k such that composition of f and g is the same as g composition with f. So part 1, we had f of x was given by 3x plus 2, and g of x was given by 6x minus k. So let's start by finding f composed with g, and by definition, this is the same as f of g of x, which will be f g of x is 6x minus k. And to define f of 6x minus k, if f of x is 3x plus 2, this will be simply 3 times 6x minus k, then plus 2, which will give us 18x minus 3k, then plus 2. Then when we reverse the order, g composed with f, we get g of f of x, which is the same as g of 3x plus 2. And if g of x is 6x minus k, so g of x 3x plus 2 will be 6 into 3x plus 2, then minus k. So which will give us 18x plus 12 minus k. And if the claim is f composed with g is the same as g composed with f, then we have 18x minus 3k plus 2 equals to 18x plus 12 minus k. So for this equality to be true, then it means that minus 3k plus 2 equals to 12 minus k, which means minus 3k plus k equals to 12 minus 2. Minus 3k plus k is minus 2k equals to 10. So this means that k will be 10 over minus 2, which is minus 5. Part 2 was f of x is given by 2x minus k. G of x is given by 4x plus 5. So f composed with g, by definition, is f of g of x, which is f of 4x plus 5. And if f of x is 2x minus k, so f of 4x plus 5 will be 2 into 4x plus 5, then minus k. This will be 8x plus 10 minus k. And then g composed with f will be g of f of x, which will be g of 2x minus k. And if g of x is 4x plus 5, then g of 2x minus k will be 4 into 2x minus k plus 5, which will be 8x minus 4k plus 5. But the claim in this problem is that f of f composed with g is the same as g composed with f. So this will mean 8x plus 10 minus k equals to 8x minus 4k plus 5. So that we'll have 8k and 8k, 8x and 8x cancels out. So which means 10 minus k equals to minus 4k plus 5. So that we have minus k plus 4k equals to 5 minus 10. So 3k equals to minus 5, so which means k equals to minus 5 over 3. And then the next question was if f of x equals to x squared minus 1, g of x equals to x minus 2, find a if g composed with f at a is 1. And then part 2, find k if f of k is 2k minus 1 and f of f composed with f at k is 5. So the claim is that Roman 1, f of x is x squared minus 1. G of x is given by x minus 2. And G composed with f at A is given by 1. So let's define G composed f of x first. So which means we'll have G of f of x, which is the same as G of x squared minus 1, which will be x squared minus 1 minus 2, which is x squared minus 3. So which means G composed with f at A will be simply a squared minus 3. And then the claim is that this should be 1. So this means a squared minus 3 equals to 1. So a squared equals to 1 plus 3, which is 4. So a squared equals to 4, and a will be plus or minus 2 by getting the square root on both sides, and remembering square root is plus or minus. So majority of the students were only writing a to be 2, yet there are two values for a, which is minus 2 and plus 2. So these two signs, plus and minus, were to be seen. And then next one, f of k is given by 2k minus 1. And the claim is that f composed with f at k is given by 5. So here we have f composed with f is the same as f of k, which is f of 2k minus 1, which will be 2 into 2k minus 1, which is 4k minus 2 minus 1. And this gives us 4k minus 3. But the claim is that f composed with f at k is 5. So this means 4k minus 3 equals to 5. And so 4k equals to 5 plus 3. And we'll have 4k equals to 8. So which means k equals to 2. So therefore the value of k will be given by 2.